This will be the second part of review 1. These are the math problems, the skills that you worked on in the chapter 1 and then the first part of chapter 2 for the integrated review. On these, the work that I show you will be the work I expect to see when you take the test. Again, if it's something that you can just look at a chart and answer the question, that's fine. But if it's something that requires you to work it out, I have to see that on your written work in order for you to get credit. So if you just enter an answer on the test and you don't show me any written work to back up your answer, when I get your written work, you won't get credit for that. I'll go back and take the points off for those questions. So just make sure you show the work that I'm going to be showing you here. All right, we're going to start with this first one that has the stacked bar chart, and there's really not any work to show on this one. You're just going to look at the graph. They wanted to know how many new customers arrived at store B during week 4. So when you look at this, store B is the one in the bright green, and you go to week 4, and in the bright green it shows 23. So this would be 23 new customers arrived at store B in week 4, and that's all you would need to do on that one. On the pie chart, they're asking you to determine what percent of the total daily calories was lunch and dinner. So you're going to come over here and you're going to add up lunch and dinner. So we have 600 and 820. So you will get the calories for lunch and dinner. And that's going to be 600 plus 820, which would be 1420. And this is the kind of work I'm going to want you to show on a question like this. And then you want the total calories for the day. So for that, you're going to add up all 4 of them. So 600 plus 380 for the breakfast, and then 200 for the snacks, and then the 820 for dinner. And you may use your calculator to add these with. So you'd add all of those up and get 2,000. And then percent, remember that percent, the easy way to remember how to find a percent is you do the part out of the whole. So what part was lunch and dinner? That was 1420, divided by the whole day was 2,000. And once again, put that in your calculator, and that comes up to 0.71. And then recall that should change from a decimal to a percent. You move the decimal 2 places to the right, so that would be 71%. And 71% would be your answer. The next few questions are conversions. We want to convert from a percent to a decimal. Okay, so we go 2 to the left. And I'm just writing that in there to help you remember. So you take your 43.07, and if we go 2 to the left, that would be 0.4307. And you take the percent sign off. Because what you're technically doing here when you change from a percent to a decimal is you're dividing out the 100. Because remember, it means per 100. So you're dividing by 100, but the quick method is just to move the decimal 2 to the left. For fractional notation, you have to remember what percent means. Percent means per 100. So that would be 15% would mean 15 per 100 or 15 out of 100. And then you would need to reduce that. I'm going to show you 2 different ways of reducing fractions. I'm going to show you a quick method on this one because it's 15 and 100. It's real quick to see that both can be divided by 5. So the quick method to reduce would be to divide by that, what you know is a common factor. So 15 divided by 5 is 3. 100 divided by 5 is 20. And that would be your simplified form or your reduced form for the fraction. On the next one, converting from a fraction to a percent, this is going to be to put it on your calculator. So you're going to use your calculator to divide 19 divided by 43. And when you divide that, it comes out to, and I kept several decimal places here, 44186, and then that gives you the decimal, but we want the percent. So remember, the percent is to multiply by 100 to get your percent, or the quick method is to move the decimal 2 places to the right. So that would be 41.86%. Pay attention on the test if they want you to round how many decimal places. So for example, if they wanted 2 decimal places, this would go up to 41.19%. because you're looking at the 6, which is greater or 5 or greater. So depending on how many places they ask you to round your answer to that number of places. On the next one, this is having to do with the positives and negatives, and it says combine like terms, which means combine the positive terms and combine the negative terms, but then you're not going to combine those at the end. You're just going to have the positive number minus the negative number. So what you want to do, and I've shown a couple of you who have emailed me questions, I showed you use a highlighter to highlight the positives and the negatives. I'm just going to underline here. So the positives would be 15. If there's no sign on it, it's understood to be positive. 3 is a positive and 4 is a positive. So you're going to get the positive terms would be 15 plus 3 plus 4. And you're just going to add those up and get 22. And then the negatives are the ones that have a negative sign in front of them or a minus sign. So we have a negative 9, and we're going to add that to a negative 13, and we're going to add that to a negative 6. Because when the signs are the same, you add and keep the signs. So we're going to add these 3 negatives, and then it's still going to be negative. So when you add that, that would be negative 28. And the way they want you to write your answer on this is just to write down the positive minus the negative. And I think on this one, it will probably have a box for the positive number to go in, and the minus sign will already be there, and then a box for the negative. So you can see that they want you to leave it like that. They don't want you to simplify or do anything with it. On the next one, we are going to add and subtract. So they want us to get just a final single answer. The first thing you want to do is eliminate the double signs. So like if you have a plus and a minus right together, or 2 negatives together, or 2 positives together. So your rule is that when you have a minus a negative, that's a negative times a negative, that becomes a positive. If they're the same, it's positive. If they're different, it's negative. And we have a plus a positive, so those are the same. So that's plus 5. A minus 18, a minus and a positive. So different would be a negative or a minus. And then again here, a plus and a negative would be a negative. So that's your first step, is to eliminate the double signs. And I'll write that out here. Eliminate double signs. And now we're going to do exactly what we did on the previous question. Find all the positive ones, all the pluses, and add those together. So I have a 12 and a 5 and an 8. And when I add those together, I'm going to get 25. And then I'm going to take my negatives, and I have a negative 32 and a negative 18 and a negative 11 and a negative 29. So since these are all negatives, we're going to add them and keep the sign. So we add those together and get a negative 90. And then you're going to put this together as 25 minus 90. And now we're going to actually subtract. So when we subtract, 25 minus 90 is 65. And the rule is when you subtract, you take the sign of the larger number. So the larger number is negative. So my final answer would be negative. So negative 65 would be the answer. On finding the product, the rule is very simple on multiplying and dividing. If you have same sign, it's positive. And then different signs is negative. So on these, I start with the first two. 5 times negative 10. 5 times 10 is 50. The signs are different because this one's positive, this is negative. Different signs is negative. And then bring down the next number, the 2. And then negative 50 times 2. So 50 times 2 is 100. Signs are still different, so it is negative. So negative 100. Next one, same thing. You start with the first 2. 5 times 5 is 25. Negative times negative, signs are the same as positive. Bring down the next number. 25 times 4 is 100. This time we have different signs, positive, negative. So the signs are different, it's negative. And then bring down the 6. 100 times 6 is 600. Signs are different, so it would be negative. The rules for quotients or dividing is the same. If the signs are the same, positive, signs are different, it's negative. So all this is negative 14 divided by 2. So 14 divided by 2 is 7, and signs are different. A negative divided by positive is a negative. On dividing fractions, you keep the first one and you change it to multiply. So we keep change, and then we find the reciprocal of the second one. So we keep it, we change the division to multiplication, and we flip the second. So we're going to keep, change, and flip. And then on multiplying fractions, you multiply straight across. So we're going to do 10 times 8 is 80, and 6 times 5 is 30. Okay, once again, you will need to reduce your fractions before you enter them in. Again, this one's an easy one to tell. 80 and 30 can both be divided by 10. So I'm going to do the quick method on this one because I can easily see that they can be divided by 10. So I would get 8/3. The next one's the same thing, but the reducing is a little bit different because the numbers are bigger. So you might not automatically know a common factor. So I'm going to show you a different way to reduce. But we set it up the same way. We keep the first one. We change the division to multiplication, and we take the reciprocal of the second one. So we flip the second one. And then we multiply straight across. 3 times 35 is 105. And 14 times 15 is 210. And you're welcome to use your calculator on that to do the multiplication. Now, these numbers are a little bigger, so you can look and see both divisible by 5. But I want to show you a different method rather than, if we divide by 5, it's still not going to be completely simplified. So I want to show you how you can simplify it all at once. So what we're going to do is we're going to break 105 and 210 down into the prime factors. So you're just looking what will go into 105. So we know anything that ends in 5 can be divided by 5. So if you use your calculator, 105 divided by 5 is 21. So 5 times 21. Now we're going to keep the 5, but 21 can be rewritten as 3 times 7. And then none of these can be broken down any further. So I'm going to come up here and I'm going to rewrite 105 as 3 times 5 times 7. And it doesn't matter what order you write those in. Okay, I'm going to do the same thing with 210. So just think of anything that'll multiply and give you 210. So the easy one is 21 times 10. 21 can be rewritten as 3 times 7. And 10 can be rewritten as 2 times 5. And then none of these can be broken down any further. So I have 2 times 3 times 5 times 7. And what you're looking for is common factors. So when I divide 3 divided by 3, I get 1. And 5 divided by 5 would be 1. And 7 divided by 7 would be 1. So all of those would divide out. And the only thing that would be left in the numerator is 1. And the denominator is left 2, so we would have 1/2 left. But just be careful here that if everything divides out up here on the top, it's not gonna disappear. That's gonna be a 1 left up there because you're saying 3 into 3 goes 1 time, 5 into 5 goes 1 time, 7 into 7 goes 1 time. And that's the second method for reducing fractions. Okay, next is adding fractions. When you're adding fractions, you have to have a common denominator. So this is where you have to ask yourself, what number will 12 and 18 go into? Okay, here's a method you can use. Start with a larger number and do 18 times 1 is 18. 18 times 2 is 36. 18 times 3 is 54. And just write out several multiples of 18. And then do the same thing for 12. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36, 12 times 4 is 48, and so forth. And what you're looking for is one that's the same, which would be the 36. So that's how you find the common denominator if you don't just recognize it right off. And here's what you have to do. You start with your 5 over 12 and your 7 over your 18, and we're having to turn 12 and 18 into 36. So you ask yourself, 12 times what is 36? So that was the third multiple, so that would be 12 times 3. What you do to the denominator, you do the same to the numerator, and then we'll do the same thing on the 18. That was the second multiple of 18, so that would be times 2, and then we have to do the same at the top. Now do the multiplication, so that would be 15 over 36, and 14 over 36. And then the rule when you're adding is you write down the denominator, the common denominator, and you add the numerators. So 15 plus 24 would be 29. And then you can check, you can't break 29, could only be broken down into 1 times 29. Nothing else will go into it. So that tells me that I'm not going to be able to reduce that or simplify. Okay, one more fraction question. It's the same thing. We're finding a common denominator. So I'm going to start with the 14, the multiples of 14. And just list out several and then go to your 4 and list several of those. So 4, 8, 12, 16, 20, 24, 28. And you're just trying to find the one that they have the same, which would be 28. So I'm going to, and if I didn't get one, then you may need to extend out the multiples of 14. So you could do 14 times 4, 14 times 5, and write those down. And you're just looking for until you can get one that's the same. So I'm going to rewrite my 13 over 4 and my 3 over 14. And then 4 times 7 makes 28. And you can do, if you've written out your multiples, you can see that that's 1, 2, 3, 4, 5, 6, 7. So 4 times 7. So I'll multiply up here by 7. And then that was the second multiple of 14. So that would be times 2. So I multiply 13 times 7. Would give me 91, and then 4 times 7 would give me 28, and then 3 times 2 would give me 6, and 14 times 2 would give me the 28. So I add these two together and get 97 over 28. And then you would check and see, can you reduce the 97 over 28? And that would again be where you would check and see what are the factors, or what will go into 97, what will go into 28, and then see if you can reduce those. So you would check if you don't recognize any right off, just start and say, well, can 97 be divided by 2? Can it be divided by 3, 4, 5, 6, 7, and so forth? And just do those divisions. And if you can't find anything that will go into it, then that's going to tell you that 97 is prime, or that 97 can't be broken down any, or you can say that 97 and 28 don't have any common factors. Okay, on the next set, this is just rounding to significant digits. And when you're rounding to significant digits, you're looking for the number of significant digits. And if you'll remember, on the number of significant digits, it was talking about whether or not the zeros count. That's the main thing on significant digits, is trying to decide if the zeros count or not. So when you do that, the rule is that the zeros count if they are behind a non-zero digit and if they're behind the decimal places. So like, for example, on this one, that 0 point, that's just you could actually write that as 0.28 without the 0. So obviously the 0 has no meaning here. So you're going 3 significant digits. So there's 1, 2, 3. So we have 0.287. So we know it's going to be 0.28. And then the question is, does the 7 stay 7 or does it go up? And so we look at the number right after it, which is the 6. 6 is 5 or greater. So that means the 7 goes up to an 8. And then that would be 3 significant digits. Now on the next one, we do have some zeros up front, but your rule is that the zeros in front don't count. If they were back here at the back, they would count, or if they were in between two numbers, they would count. But the zeros in the front don't count. So those two zeros are going to go down and not count as significant digits. And then we start at the 9, the 4, and the 1 would be the third significant digit. Again, you have to look to the right. Does the 5 make it go up or stay the same? Anything 5 or greater rounds up. So the 1 would go up to a 2, and that would be your 3 significant digits. Okay, and then the last one is putting in numbers in order from least to greatest. Your least number is going to be, the way I say it is the most negative. Okay, which one is the furthest to the left of 0? So if you look at your negatives, the one that's the farthest to the left would be the negative 14. So that would have the least value. And then negative 5, and then negative 2. And then you move to your positives, or if you had a 0, you could put a 0 in, but then you move to your positives. And then, of course, 7 is the smallest of the positives, and then 10, and then 11, and then 12. And that would be in the order from least to greatest.